So on this section, 6.3, we're going to be graphing square root functions. And let's start by graphing with the XY table. And when we graph with an XY table, we simply plug in the values that work for us and find out the outputs, right? So what numbers would be good to plug in? 0 is great because when you do the square root of 0, you get out a 0. Yes, another one is 1 because when you plug in 1, the square root of 1 is 1. What else?
1.
What else could he plug in? 2. 2 doesn't work out that great because when you do the square root of 2 on a calculator, let me just tell you that, when you do the square root of 2 on a calculator, it's 1.4142135662. So 1.4142, and it keeps going, right? Okay, so that one's an irrational number. It's ugly, but nevertheless, it's still a coordinate on an XY plane, okay? But what's a nice number to plug in? 2 is not a nice number. 4 is a nice number because the square root of 4 is 2. 9 is a nice number because the square root of 9 is 3. You guys get the idea? Yes, 16, 36. So if I did go 36, I would get out a 6. But you see, I'm not going to use the coordinate 36, 6 because obviously this is a 10 by 10 graph. So 36 is way off the graph. So I'm going to stop at 9, 3. But those coordinates give me my graph. And of course, it continues forever. But let's also make it clear that you can't plug in negative numbers. If you plug in -1 and you take the square root of -1, that's actually 1i. And 1i is not on this graph because it's not a complex plane. It's a regular XY plane. These are imaginary values, so you don't want to plug in any negative numbers into your square root function. Anyhow, let's graph this thing. Let's go to 0, 0. 0, 0 is right here. There's 0, 0. If we go to 1, 1, it's right here. If we go to 4, 2, 1, 2, 3, 4, up 2, it's right there. Whoops. And if we go to 9, 3, 9 on the X, 3 on the Y, you get right here. And as you could see, it's a curve. It looks like a line, but then it curves this way. And that's my graph of the square root function y equals the square root of x. Hopefully you guys are following along here. Now, even if I would have graphed this ugly number 2 and the irrational number 1.4142, so 2 and 1.4, that still lands on it. 1, 2, 1, 2, and then 1.4 is about right there. It still lands on the curve. But the nice coordinates are 0, 0, 1, 1, 4, 2, and 9, 3. Now, of course, even 36, 6 is also on this graph, but you would have to go way over here, 36, way over here, and then 6, right? So it's still on that curve, but it's way off the graph. So in addition to graphing square root functions, we also need to be able to state the domain and range of these square root functions. So let's talk about the domain. The domain are your x values, and let's take a look at the x values of this graph. Does this graph exist anywhere on the negative x values? No. It all starts here at this point and it goes in the positive direction forever, right? So what kind of domain do we have on this square root function? X is what?
X is greater than 0.
Greater than or equal to 0 because there is an actual dot at the x value of 0. It's included. Okay, and now how about the range? The range are your y values. Now the range could be a little bit more interesting because people think, oh, it's a curve and then it all of a sudden flattens out, right? But it never flattens out. As we saw earlier, the coordinate 36, 6, right? So thinking about square roots, if I went out 9, I got out 3. What if I would have gone out 16? I would have gotten out 4. If I would have gotten out 25, I would have got out 5. 36, 6. So the further you go on your x's, the higher it goes on the y's. So does it ever completely flatten out? The answer is no. It continues to rise higher and higher and higher forever. For example, if I did the input of 81, what would the output be? It would be 9. But if I did the input of 100, the square root of 100 is 10. So I could keep plugging in higher and higher x values, and I will get higher and higher y values. So the range, it really does continue to go up forever. And as you can see, this graph, none of it is in the negative y values. It all starts here and is above that value. So what do I say about the range? Greater than or equal to 0 also. Okay? Now, ladies and gentlemen, this is a very important graph. This is called the parent graph of all square root functions. This guy right here, y equals the square root of x, that's the parent graph of all square root functions. Now, what do I mean by parent graph? A parent, you know, when parents have kids, the kids look like the parents, right? They have similarities in the way they look. So any square root function is going to look like this. Any square root functions are going to look like this. But sometimes the square root functions get shifted. Like maybe it doesn't start at 0, 0. It might start at 0, 5 or something like that. And it shoots off in that direction, same curve. Or it might be reflected on the x-axis. Or it might be stretched and the curve is a little bit higher up like this. Or it might be flattened out and it's a sharper curve closer to the x-axis. But all square root functions are going to end up kind of looking like this. And technically they're all really just this graph changed in some sort of way. Like I said, it might get shifted to the left, it might get shifted up or down or maybe this way. But they're all going to look like a curve that start off at a certain point and shoot off in one direction. Okay, so keep that in mind. Let's take a look at this one down here. Graph y equals negative square root of x. So once again, if we were to make an xy table, an input-output table, and what numbers would be nice to plug in? 0 would be nice. When I plug in 0 into here, it's the square root of 0, but you have a negative in the front. So your output's negative 0, which is still 0, which is still the coordinate 0, 0. So if I go to the coordinate 0, 0 and put a dot right there, that is an ugly dot, but you guys get the idea. If I plug in other numbers, another nice number to plug in, again, would be perfect square numbers like 1, like 4, like 9. And when I plug in 1, I want to get out the square root of 1. The square root of 1 is 1, but there's a negative in front, so that's going to be a negative 1. The square root of 4 is 2, but there's a negative in front, so your answer is going to be a negative 2. The square root of 9 is 3, but there's a negative in front, so you get a negative 3. And if you graph these coordinates, the 0, negative 0 is still 0, 0. But if you go 1, negative 1, you end up right here. And if you go 4, negative 2, 1, 2, 3, 4, negative 2, it's right there. And if you go 9, negative 3, it's right here. So as you could see, it's like the same exact curve as the parent graph, but what could you say is different about it? It's a reflection over the x-axis. Now, we already knew that. We already knew that because we already knew, like back when we did quadratics, y equals x squared, that looks like this. Now, we know that if we went for y equals negative x squared, if we threw the a value and changed it to a negative, then what would happen, it was the same parabola, but it would just get reflected on the x-axis. It opens down instead of up. It's the same exact concept. The a value is negative. It gets reflected over the x-axis. Let's try this next one down here. This one has a minus 2 on the outside of the square root. So once again, if we went to the xy table, plugged in some numbers, like perfect square numbers that work, like the square root of 0 is 0, the square root of 1 is 1, the square root of 4, and the square root of 9, those all work. But remember, we have a minus 2 at the end of each one of these. So when I say 0 inputted right here, the square root of 0 is 0, but 0 minus 2 is negative 2. When I plug in 1 right in here, the square root of 1 is 1, but 1 minus 2 is negative 1. when I plug in 4 into here, the square root of 4 is 2, but 2 minus 2 is 0. Let's go for the last one. The square, when you take the 9 and plug it in there, the square root of 9 is 3, and 3 minus 2 is 1. So we have these coordinates. Let's see how this outside minus 2 changes our parent graph. So instead of 0, 0, it starts out at 0, negative 2. So I put the red lines on the x and y axis so it'll be a little more clear when we graph this stuff. So let's start with 0, negative 2. 0, negative 2 is right here. And then we have 1, negative 1. 1, negative 1 is right there. And we have 4, 0. 1, 2, 3, 4, 0 right there. And we have 9 and 1, which is right there. So if we compare this one to the original parent graph, what difference is there?
It's been translated down to.
Translated down 2 units. That's exactly right. It got shifted down 2 units. The correct word in mathematics is translated down 2 units. So this exact curve that started at 0, 0 and went up in this direction just got shifted down 2 units, and it shoots off in that same exact direction. It's the same exact curve. It just got shifted down 2 units, and that is because of the minus 2 being on the outside of the square root. So this minus 2 shifted it down 2 units. It used to be at the origin 0, 0. Now it's down here at 0, negative 2. If this would have been a negative 5 or a minus 5 at the very end outside of the square root, it would have started at negative 5 and that same exact curve at negative 5. If it would have been a plus 5, then it would have been up here shooting off in that direction, same exact curve. So are we seeing the relationship here on how the outside number affects the graph? I hope so. Let me stop right here, and I forgot to mention the domain and range of each of these. So let's go back to this guy. The domain, if you think about the x values, right? These are the x-axis. And this graph is nowhere on the negatives on the x. It's all from the x value of 0 going to positive infinity. So the domain would simply be x is greater than or equal to 0. Now the range, when you're talking about the y values, well, there's no part of this graph up here. It's all down here. So y is definitely less than or equal to 0. By the way, the key word to receiving extra credit is broccoli. Once again, the first person that replies to this video and posts the word broccoli, only the first person, not everybody. Whoever responds first with the word broccoli will get extra credit on their next quiz. Okay, so moving on. Let's go to this bottom one right here. It's the same exact curve. It's just shifted 2 units down from the parent graph. So this guy, the domain would be x is greater than or equal to 0, because once again it's still at the x values of 0, and it's all on the right side of 0, right? It's all going that way forever. And the range would be y is greater than or equal to, it's all above this level, right? It starts here and it's all above it. So it never goes, see, it never goes below this y value, which is a y value of negative 2. So what do we say about the range? Y has to be greater than or equal to negative 2. I hope that makes sense, guys. We're going to pick it up from here on the next video.